Next, theorem number 3. Let eta be the one form on R2 minus 0 defined by eta equal to minus x2 divided by x1 square plus x2 square dx1 plus x1 divided by x1 square plus x2 square dx2. Then for alpha from closed interval AB to R2 minus 0, any closed piecewise smooth parameterized curve in R2 minus 0, integral over alpha eta equal to 2 pi k for some integer k. Okay, we want to show this. So proof: define phi from closed interval AB to R by phi of t equal to phi of a plus integral of eta over alpha t, where alpha t is the restriction of alpha, okay, to the closed interval at, and phi of a is chosen so that alpha of a divided by norm alpha of a equal to cos phi of a sin phi of a. Okay, now we claim that alpha of t divided by norm alpha of t equal to cos phi of t sin phi of t. Okay, here note that phi is smooth except at the points where alpha is not smooth. Okay, now we claim that for all t belongs to AB, alpha of t divided by norm alpha of t equal to cos phi of t sin phi of t. Okay, so this is our condition star. Say t naught equal to least upper bound of the set of all t tau in closed interval AB, okay, such that this condition star holds for a less than or equal to t less than or equal to tau. Okay, therefore by continuity star must hold at t equal to t naught. Okay, so that means that is alpha of t naught divided by norm alpha of t naught, which is equal to cos phi of t naught sin phi of t naught. Okay, so this is our equation number 1. Now we choose small v equal to minus alpha of t naught divided by norm alpha of t naught. Okay, now let capital V, which is equal to this R2 minus set of all RV such that R greater than or equal to 0. Then in capital V, this eta is x hat. ഇത് already നമ്മൾ കണ്ടാണ്. Now since alpha of b which is in V, okay, which is open in R2, now using the continuity of alpha, at t naught, there exists delta greater than 0 such that for all t in t naught minus delta, t naught plus delta, alpha of t belongs to v. Now define theta v as in the above example. That means cos theta v alpha of t sin theta v alpha of t, which is equal to alpha of t divided by norm alpha of t. So this is our equation number 2. Now from 1 and 2, cos phi t naught sin phi t naught, which is equal to cos theta v alpha of t naught sin theta v alpha of t naught. So this implies phi of t naught minus theta v alpha of t naught equal to 2 pi m for some integer m. Okay. Now for delta greater than 0 with t belongs to t naught minus delta, t naught plus delta, then derivative of this phi of t minus theta v of alpha of t with respect to t, which is equal to d phi by dt minus d by dt of theta v alpha of t. Okay, so that is equal to d phi by dt eta of phi dot of t minus theta v composition alpha dash of t. So this is equal to d theta v alpha dot of t minus d theta v alpha dot of t. So this is equal to 0. Okay, so that means for t belongs to closed interval t naught minus delta, t naught plus delta, phi of t minus theta v of alpha of t equal to a constant. Okay, now by 3 phi of t naught minus theta v alpha of t naught, which is equal to 2 pi m. Okay, that is for all t belongs to t naught minus delta, t naught plus delta, cos phi of t sin phi of t, which is equal to cos theta v alpha of t sine theta v alpha of t. So this is equal to alpha of t divided by norm alpha of t. Okay, then there exists t which is greater than t naught such that our condition star is satisfied. Okay, so this is possible only t naught equal to p. Okay, thus cos phi of b sine phi of b, which is equal to alpha of b divided by norm alpha of b. Okay, that is equal to alpha of a divided by norm alpha of a, since alpha is closer. So this equal to cos phi of a sine phi of a. Okay, so this implies phi of b minus phi of a equal to 2 pi k for some integer k. Now integral of eta over alpha, which is equal to integral a to b eta of alpha dot of t, which is equal to phi of b minus phi of a, okay, which is equal to 2 pi k. Okay, so we have phi of t equal to phi of a plus integral a to t eta of alpha dot of t dt. Okay, so what is phi of b? Phi of b equal to phi of a plus integral a to b eta of alpha dot of t dt. Okay, and therefore integral a to b eta of alpha dot of t dt, which is equal to phi of b minus phi of a. Okay, so that's why we have this one. Okay, so this completes the proof. Now the integer k of alpha which is equal to 1 by 2 pi into integral. So this k, which is equal to 1 by 2 pi integral eta over alpha, this k is called winding number, okay, of alpha, since it counts the number of times the closure alpha winds around. Okay, now let's consider an exercise. Now let's consider this exercise 11.5. Find the length of the connected oriented plane curve f inverse c oriented by del f by norm del f, where f is from u to r and c are as given. So f of x1 x2 equal to 5x1 plus 12x2, where u equal to set of all x1 x2 such that x1 square plus x2 square, which is less than 169. Here c equal to 0. So given f of x1 x2, which is equal to 5x1 plus 12x2. Okay, 5x1 plus 12x2, and u is the set of all x1 x2 such that x1 square plus x2 square, which is less than 116. Now let alpha of t which is equal to x1 of t, x2 of t. Now put x1 of t equal to t, then our this f of x1 x2 becomes 5t plus 12x2 equal to 0. Here c equal to 0. So this means x2 equal to minus 5t divided by 12. Okay. Now alpha of t equal to t minus 5 by 12t. So x1 square plus x2 square, which is less than 169. Okay, then so this means t square plus 25 divided by 144 t square, which is less than 169. So this implies t square into 1 plus 25 divided by 144, which is less than 169. So this implies 169 divided by 144, which is less than into t square, which is less than 169. So this implies t square less than 144, or this t lies in between minus 12 and plus 12. Okay, so what is L of alpha, which is equal to integral of norm alpha dot of t dt over alpha. Okay, so we have alpha of t equal to t minus 5 by 12 t. So alpha dot is alpha of t 1 minus 5 by 12 t. Okay, so what is norm alpha dot, which is equal to root 1 plus 25 divided by 144 is equal to root 169 divided by 140 equal to 13 by 12, and therefore L of alpha, which is equal to integral minus 12 to 12 13 divided by 12 dt, which is equal to 13 divided by 12 into 24, that is equal to 26. Now another exercise 11.14. Let C equal to f inverse C be a compact plane curve oriented by del f by norm del f. Let x be the unit vector field on U, which is equal to domain of f obtained by rotating del f by norm del f through the angle minus pi by 2. And let wx be the one form on U dual to x. Show that integral over C wx equal to L of C. Okay, so solution: let alpha from close interval a b to c be a Gaussian parameterization of x such that alpha is from close interval a b to c 1 global parameterization for each t belongs to AB. Now alpha dot of t which is equal to x of alpha of t. So integral of wx over c, which is equal to integral over alpha wx, which is equal to integral a to b wx of alpha dot dt. So this is equal to integral a to b x of alpha of t dot alpha dot dt, that is equal to integral a to b x of alpha of t, alpha dot of t t means x of alpha of t. So this means integral a to b norm x alpha of t square dt is equal to integral a to b dt. Okay, so this is actually b minus a. B minus a is length of alpha. This is equal to our L of c. Okay.